Okay, so in the last video ended, we were on number 20. We had our 4-kilometer vector drawn in that was going north 35 degrees east. We drew our 6-kilometer vector that was perfectly going west. That was the one I was on just as the video ended. And then it says the next one is north 30 degrees west. So from the north, measure down 30 degrees. Okay, and this one is 6 kilometers, which on my scale needs to be 12 centimeters. Okay, see if I can balance this so it doesn't fall. Pull this down. So 12. It's going to be right there. Wow, it's just going to make the page. Look at that. It just makes it on the page. Okay, and so this is 12. Oh, sorry, this is 6 kilometers. It's 12 centimeters. 6 kilometers. My arrowhead is up here. My resultant is going to be here. I think it looks like an airplane seat. Okay, and you're going to measure it. And then you need to convert it back. So when I measure, I get just over 18. So when I convert it back, I get 9. 9 kilometers. You might have 9.2, 9.3, depending on your scale. And then, of course, you're going to measure down here. And you can either measure from the east or the north. I'm going to measure from the east just because I can see it better because it's late at night. Actually, I'm going to measure from the west, I should say. So it's going to be west, and I get on this one 68 degrees. Sorry, just checking. Let's see. Right? There, if I line it up like that, I get 70, sorry. So I get west 70 degrees north. If you did it the other way, it would be north, something in the area of 20 degrees west. Okay, so that's the first part of the question. Determine the displacement. And then it's draw a vector. Then it says determine his average velocity for the trip. So his average velocity for the trip, again, is VAV is equal to delta D over delta T. So his displacement, which we just found, and I found to be 9, you may have found to be a little bit different. And then you have to add up the total times. So you have to go back here. We had 48 minutes, we had 40 minutes, and we had an hour and a half. So 48 minutes, I had said earlier, 48 over 60 reduces to 4/5 of an hour, plus 40 minutes over 60 reduces to 2/3 of an hour, plus 1.5 hours. It's going to give you 2.96 repeating of an hour. So over here, 2.96 with the 6 repeating of an hour. So the average velocity for the trip will be that divided into 9. And you get something like 3.034 kilometers per hour. Now your decimals will be a little different if you didn't get 9 right on the nose. And then of course the direction will either be west 70 degrees north or north 20 degrees west. Okay? Determine his average velocity. Yeah, and that's it. So this is part B and this is part A. Okay? All right, as promised, let's go back to number 19 if you happen to be in the class where we didn't finish it. So number 19 told us that first his VAV1 was 3 meters per second north, and that he did that for 30 minutes, which of course is a half hour. And his VAV2 was 4.5 meters per second, and, 2.5 meters per second. And that was west. and he did that for 15 minutes. Delta T2, 15 minutes, which is a quarter of an hour. So just like we did above, we have to find the delta D's. So we know V average is average velocity is equal to displacement over time. So multiply both sides by the time. So V av times delta T. So 3 meters per second times a half hour. Oh, wait. You don't want to go to a half hour, you want to go to minutes or seconds. Sorry, I went the wrong way there. Be good if I looked at the units of my velocity. So a half hour is 1800 seconds. So our delta D1 is going to equal 5,400 meters. And our delta D2 is going to be 2.5 meters per second, and a quarter of an hour is 900 seconds. So delta D2 should be 2250 meters. This guy will be west, that one will be north. So we can now draw our vectors. 54, 22. I don't know, what scale should we use? Looking to see what I did when I drew my picture. Maybe if you did 1 to 50. Okay, so 1 centimeters equals 50 meters. Because or 500, sorry, not 50, 500. That would make this one 10.8, and that would make this one 4.5. That's reasonable. Okay, so we're starting down here, reasonable, but I don't want to go off the page. You need a vector that's 10.8 going directly north. So maybe I'll just start over a little. 10.8 will be like here. 10.8 north, and so this is 5,400 meters. Whoops, you can't see it, but there it is. And then the other one is going to go, oh yeah, always plan ahead. Okay, let's try that again. 10.8. Switching pens too. Okay, so this is my 5,400 meters north. And then my other one was 20, it's going to be 4.5, and it's going west. So 2250 meters, and that's west. So my resultant then will be right in here. Okay, so measure it. I get 11.5. Forget what my scale was. So 5,850 when we go back, right? Because it was 11.5 and I used 50. So 5,750. I do well in my head. So 5,750. So 5,750, probably anywhere between 5,700 and 5,700 to 5,900, depending on your scale, would be something that was acceptable. Now measure your angle down here at the bottom. If you measure from the north, line it up with your north line, I get like 22 degrees, 22 or 23, so it'd be square bracket north, say 23 degrees west. Okay, so there's my answer. As the question asked for, determine his displacement. So you need both a size and a direction. Okay, hopefully these are getting good. Hopefully you can handle in the protractor now.